What stumped me until today was that I couldn't get the hexagon appearing sun to behave consistently while I did the camera tilt test. And as you do the test, just as a reminder, you watch one of the vertices. If it rolls with the camera at the same angle, then the hexagon is very, very likely to be an effect from the perceiver's side. But yet, I have other videos where I do believe I legitimately have a hexagon-shaped sun that passes the camera tilt test. So, this was baffling me. As I continued to shoot, the sun got too bright for the camera, and every time I would go and try to shoot it, the light would drown out all the detail around it. So I pulled up a piece of tissue paper, among other things, and was messing around with the camera some to see if I could darken the whole thing and maybe get a better view of the little white sun or the hexagonal sun. The tissue paper was unproductive. I got lazy, went off the balcony, and had a seat. I was watching the sun on my tablet still, but through the screen door. It had this peculiar property of making it a diamond instead of a hexagon, more like a square shape. So, in observing it, I took down 3 properties. It's that it bends light, it passes light, and it absorbs light. These 3 properties, are extraordinarily useful, I think, in explaining some of the phenomena we've seen in other videos. We're going to ignore that it's not a hexagon for now. The whiter light is caused by the flare on my camera, and as I tilt that around, you can see that the lit up shape, that square or diamond that it produces, stays there independently, and it doesn't tilt because obviously it's not attached to the camera, meaning that the light bending effect or light manipulation occurs somewhere upstream. If we can bend the light, we can also block the light, and we can also redirect the light. If those things are possible, it may explain why it is we see certain things disappear out of the sky. For example, if you hold a fence sideways or obliquely and try to look through it, no light really gets through there, so you can't see through it. But if you reorient it so that the holes are facing toward you, the light has more space to travel through, increasing the visibility of it and the brightness of it. This is what I mean when I say the lattice can let light pass through it. The last point is that it can absorb some wavelengths. Notice that in the video clip, just like with the older videos we've seen where there's a yellow and a white light, the light coming out of the lattice that's reflecting off of the metal on the mesh, it's coming out a little bit yellower. This is because whatever material it's made of, it absorbs more of the red, orange, yellow end of the visible light spectrum. Visiting the issue of the hexagonal shape that we're seeing. My theory right now, and I don't have enough to say definitively either way, is that it comes up as a square or a diamond shape because the shape of the lattice or the structure of the lattice is in a square shape. I imagine, possibly, if there's some kind of honeycomb structure with hexagons, that it might look differently. Before we move into the composition of the lattice, I'm going to play a short clip that I think is helpful and relevant. One of the most interesting things is watching the change between the yellow light and the white light correspond with the amount of cloud cover and possibly the type of cloud cover. Here comes the zoom in. So take a look at how it changes from a yellow light to a white light. It's not all at once. It happens as the clouds come over it, and it follows the outline of the cloud. So right here, you're going to see it move up into another cloud, and the quality of it is going to become whiter. The aura is entirely stripped away as it enters this next cloud, and it just becomes the round little white sun. In rendering the opinion, the scientist reviewed all of the videos, has been updated on the observations and hypotheses going on so far. It was agreed that whatever is in the clouds is blocking light. What they're publishing now is bending light with silicon nanoparticles. I'd encourage you to take a look at some of these in details, but they can manipulate some major properties, and very effectively too. They're also discovering that nanocrystals have a self-assembly property. This published in March 24 of 2016, funded by the U.S. Department of Energy. Finally, they're seeing that nanotechnology can do way more than bend light. It can create structures like lattices, superlattices as they call them, and they can perhaps cloak a sun